Hi, ma'am.
Okay, let us start today's tutorial. I hope my slides will be visible to you.
Yeah, ma'am.
Okay, thank you very much.
Ma'am, I have a doubt about last class.
Yes, I saw your question. So, for
Yeah,
salicylaldehyde, you asked, right?
yeah, ma'am.
Yeah. So, for salicylaldehyde, it is not necessarily you have to go clockwise or anti-clockwise. You just have to choose a direction where the number which will be assigned to the substitution will be the lowest. So,
Okay.
suppose you want to put hydroxy group in the left side, then also you
Yeah,
can call it 2 hydroxy benzaldehyde. Or if you want to put it on the right side, then also it will be 2
yeah,
hydroxy, because if you put it on the left side and then we decide to go clockwise, then it will be
yeah,
5 hydroxy, right? Which
yeah.
yeah 6 hydroxy, so it will be assigned a very high number. So that is why it is
Yeah.
irrespective of clockwise or anti-clockwise. But you just remember that you have to assign the numbers to the substituents in such a way that it is the lowest one. So I hope you got your answer.
So when your question, what we write at the when you give some homework, there is a that, that is a hydroxy group in the left side of carboxylic acid.
Okay.
That time, what we use?
Um,
What name? What,
Let me go to the question. Uh, it is this one, right?
yeah, here we use numbering clockwise direction.
Hmm.
In the above question, in the previous slide, I think there are a lot of compounds.
Okay, so in this compound, since we are going from alphabetical order, so bromo will come first, and the multiple bond will be assigned higher priority. So if you
Yeah,
suppose we want to assign higher priority to this multiple bond, then the number of substituents will be 1, 2, 3, 4 in such a way.
okay.
2 and 4. Or if we want to go in this direction, then it will be 1, 2, 3, 4. But the alphabetically first whatever will come, that will be given the lowest number in this case.
Ma'am, when we start numbering from chlorine, that time one three one one for chloro and three for bromo, one chloro, three bromo, chlorpenta, one three diene like that.
In this way you are saying.
That is clockwise direction. We put chlorine one number.
Yeah, 1, 2.
Then what was the
But in that
then diene also the
but in that case, this single bond is going to get the lowest number, like 1, 2.
Oh, okay.
Huh.
Okay. That time we choose multiple, we prefer multiple bond also.
Yes, multiple bond should be getting the highest priority.
Ma'am, please go the previous slide also. There is salicylic acid.
Uh,
Yeah, that I think that. No, ma'am. Start. Yeah, this one. This
this one.
please, for fifth question.
Hmm, hmm, hmm. Okay, so in this one also you can go either clockwise or anti-clockwise.
Yeah,
If we go clockwise, then this substituent will get number 6.
yeah.
But if we go anti-clockwise, then it will get number 2.
Oh,
So choose that
yeah.
number which will be the lowest that will be assigned to the substituent.
That time we look upon the priority of subsequence, not
Yes,
upon
yes,
clockwise. Or,
yes.
yeah, okay, ma'am. Now it's clear.
Because in this structure you don't have to look for multiple bond versus single bond. All the bond lengths are same only.
Okay. Now it's clear, ma'am. That case, we want to, when first priority, when we consider the rule, that time we look upon the lowest numbering on the subsequence.
Yeah.
There is no issue of multiple bond also. We consider that also.
Yes.
Okay, ma'am. Now it's clear. Thank you.
Yeah. But then if you suppose you have to choose between multiple bond priority versus substituent number priority, in that case always go for the multiple bond priority.
Okay. Yeah.
Yeah.
Ma'am, I have one request also. This time also, you continue for you for class, live class. I think this is the same, this same type for coordination chemistry class also. I can't join both, but I need to develop my organic basic more. That's why I compulsorily join in this class.
Can you repeat? I'm not. Uh,
This same thing, digital coordination chemistry class also.
hmm.
Could you please change any time or any day or any time?
Okay. You are
I
talking about the
already
time
met.
slot.
Yeah. I already messaged regarding these two coordination class also. I can't join. They didn't reply anything. I don't know their timing, anything. I think this is the fixed time every day. I am late to join the class because on the same thing we want to continue all the week. That's why I just try to join the day. I didn't will as of I think our new week will come new link joining the class.
Actually, I have not received any mail of timing change.
No problem, ma'am. I already messaged to coordination chemistry department about this,
Okay.
but I also didn't receive any mail about that. No problem, ma'am. You continue. Yes.
Okay. Okay. So let us continue for today's tutorial, which is the tutorial 2 of the course Symmetry, Stereochemistry and Applications, conducted by NPTEL, whose course instructor is Professor Angshuman Roy Chaudhary from Aizar Mohali. I am Deepika, your PMRF teaching assistant. I am doing my PhD in chemistry at IIT Bombay. So, in this week's lectures, if you have gone through, it included symmetry elements present in organic molecules as well as their point groups. So, let us start with simple questions first. The question goes, what is an element of symmetry in a molecule? So, 4 options are given. I hope there is not much explanation is required here. So symmetry element in a molecule is basically a geometric operation that maps a molecule onto itself. So there are various symmetry elements that can be present in a molecule which can convert the molecule onto an identical position of itself. So Professor Roy Chaudhary have talked about various such symmetry elements in his lectures. So let us see what is this question talking about. Which operation is always present in every molecule? So there is this one symmetry element which is called identity, which basically means no change in the object, and in all molecules, irrespective of it being symmetrical molecule or asymmetrical molecule, it will always contain the symmetry element which is called identity. And it can also be shown in this picture. So it converts itself into an identical position. So out of these all four possible options, center of inversion, mirror plane, identity, and improper rotation, the correct answer will be the identity symmetry element. This is present in all molecule, every molecule. So next we have this question: which symbol denotes a mirror plane that is perpendicular to the principal axis? Out of sigma V, sigma D, sigma H, and sigma T. Sigma T
H.
is, yes,
Sigma H.
yes, correct. So as we know that if Cn is the axis of principal axis, then the plane which will contain Cn will be sigma V, and the plane which will be perpendicular to the principal axis, it will be called the sigma H plane. Hence, the correct option is sigma H. Next, let us talk about inversion center. What is the defining action of an inversion center? Is it rotation by 90 degree about an axis, which is equivalent to C4, reflection through a vertical plane, mapping XYZ to minus X minus Y minus Z through a point, or rotation followed by translation? So for your reference, I have put a picture here, okay? So if we are talking about a mirror plane, then it will absolutely mirror the image which is given. That means the things which are towards the left will come towards the right, and everything else will also fall into the places accordingly. But if we are talking about the center of inversion, then each and every point which is present on the object will be inverted. Okay, not only the left right will go accordingly, above down points will also move and they will be inverted. Hence, out of these four options, we have to choose mapping XYZ to minus X minus Y minus Z, because the changes are occurring in all three axes in space. Okay, hence center of inversion I will denote such a change on an object. Then we will talk about an improper rotation axis, which is denoted as Sn. So this question is given with four options: rotation followed by translation along the axis, reflection followed by rotation about an axis perpendicular to the plane, rotation by 360 degree by n, and a mirror plane combined with inversion center. So improper axis of
Reflection
rotation,
is
yes,
perpendicular to that.
yes,
B option, ma'am.
Very good. So the definition you can see here: imaginary axis on which molecule, when rotated and reflected on a plane which is perpendicular to the rotation axis. Hence, the molecule which will lie on space in this way will change its position after following the Sn element, and hence it will be defined in such a way. After that comes sigma v. This should also be very easy to you. Which element of symmetry is represented by sigma v? A vertical mirror plane that contains the principal or perpendicular to the principal
Option.
axis, or inversion center or n-fold rotation axis. So sigma v is a vertical mirror plane that contains the principal axis, like we have already talked about. Then, if a molecule has an S2 improper axis, this operation is equivalent to which symmetry element? So out of sigma, E, I and C2, out of these four options, there is one symmetry element which is identical to S2. So we have already talked about Sn. Sn is what? A axis of symmetry
Principal.
and also a plane which is perpendicular to that. So center of inversion will be equivalent to S2 because both of these will produce the same change. Next we have, which of the following molecules is achiral despite having stereocenters due to an internal mirror plane? So out of mesotartaric acid, lactic acid and thalidomide enantiomer. So you can see lactic acid enantiomers are given here, L and D, and thalidomide enantiomers are also given here, where the stereocenters are denoted as R and S. And if we go to mesotartaric acid, you can see that there are two stereogenic centers present in the molecule. Okay, but this molecule, as you can see, contains a plane of symmetry. So despite having two chiral center present, because of this plane of symmetry, mesotartaric acid is optically inactive and hence it is achiral. Okay, so out of these three compounds, option 1 will be the correct one. In this way, you can also note down in the molecules where even if they have chiral center, if the molecule contains a plane of symmetry, like you can divide the molecule into two equal and identical halves, then the molecule will be achiral or optically inactive. So next we have, which of the following point groups commonly describes staggered ethane? Is it D3D, D3H, C3V and C2V? So okay, so staggered ethane has a structure where you can rotate it by its principal axis C3, and it contains three vertical mirror planes. Okay, let us go back to the flow chart of symmetry. Okay, so here I have put the flow chart, point group flow chart of symmetry. If you follow this flow chart, you will realize that the symmetry elements which are contained by the staggered ethane will fall in this zone. Okay, hence Hence, the point group which will be given to staggered ethane will be D3D. And this question has also been solved in the video lectures already. Okay. Next, which point group contains a mirror plane but no rotation axis except the identity? That means the molecule will have a mirror plane symmetry, but you cannot rotate it by any angle to bring it to an identical position. So out of all these, as we know that CS group is such a point group which has only two symmetry operations, a mirror plane and the identity operation. For example, you can look at the NHF2 molecule. So this NHF2 molecule has an identity operation and the reflection in this direction. Okay, it is a tetrahedral symmetric molecule, but if we place the lone pair and the three substituents present on the nitrogen atom, the shape will have a CS point group. Then, which element distinguishes Cn from Sn? So, out of all these four options, it says Sn involves rotation only and Cn involves reflection, which is incorrect. Sn is rotation followed by reflection in a plane perpendicular to axis, while Cn is pure rotation. So, this option is the correct one, as we have already gone through the definition of Sn symmetry element. Okay. Hence, the option 2 will be the correct one. The plane of reflection, which is perpendicular to the axis, is the factor which distinguishes Cn from Sn. Then we have the molecule SF6. Which point group does an octahedral complex like SF6 belong to? So, SF6 molecule, which is having an octahedral geometry, if you go through the, yes, if we go through the point group flow chart, you can see that is SF6 linear? No. Hence, we will have to move in this direction. So, is it belonging to the classes tetrahedral, octahedral or icosahedral? Yes, it does. So, if it is an octahedral molecule, then its point group assigned will be the OH point group. Similarly, the tetrahedral geometric compounds are assigned TD point group. Okay. And if you want to go deeper into the symmetry elements present in OH point group, so I can show you one website where I came across the various symmetry elements present. Let me show you quickly. Yes. So in this website, when I was going through, this is an octahedral molecule. For example, SF6. Here, the S6 operations are shown. You can take your time, and if you want to understand it clearly, you can go, and if you click on show symmetry elements, you can see all the different symmetry elements present. And if you go down, separately all the symmetry elements can also be seen like this. these are the C4 present here. And for example, I want to see S4 axis. It can also show you the S4 axis present in the molecule. So in this ChemTube 3D website, you can go and check the various symmetry elements in the octahedral, tetrahedral, etc. point groups.
Okay, ma'am. Thank you.
Okay. The same thing I had included in the slide as well. So next, the molecule with a C2 axis of symmetry among the following is BH2Cl, CH3Cl,
Option two.
NH2Cl, and HOCl.
Option two.
Yes,
Option two. CH2.
yes. So if we write the molecule BH2Cl, it will be having such a planar geometry, and the principal axis C2 will pass through here. Hence, out of all these molecules, and if you look at the other molecules, these two will be having a tetrahedral geometry, which will not have a C2 axis of symmetry. Hence, the option 1, BH2Cl, will be the correct answer. Okay, I'll just take a 2-minute break. After that, we will continue from the next slide. Is that fine?
Yes, sure, ma'am.
Okay. Okay, so let us continue from the next question. So here is the explanation for the last question. As you can see, CH3Cl, NH2Cl, and HOCl do not have a C2 axis of symmetry because they do not have two identical substituents on opposite sides of a central atom. Hence, C2 axis will not give you the same identical position of the substituents of the molecules. So the next question is, a cube does not have the symmetry element C2, C3, C4 or C6. So these are the definitions of the various symmetry elements which are listed on the question. And if we talk about the point group of a cube, C6 is not present on a cube, okay? Because if you rotate a cube by a C6 axis of symmetry. For example, if we talk about C2, C3 and C4, in the point group, these axis of symmetry will give you the identical position of the locants. Okay, you can go through the video lecture where you can see how you can assign the symmetry elements presence on a cube. Hence, out of these four options, C6 will be the correct option. Next question says the point groups of cis and trans 1,2-dichloroethylene are respectively. Out of these four options, you have to choose. Let us draw the molecules cis and trans 1,2-dichloroethylene. So, this is the cis 1,2-dichloroethylene, where you can see the principal axis go through this side, which is C2, and a sigma V plane which is present in this direction can divide it into two equal halves. Okay, hence the symmetry elements possessed by it are C2 and sigma V, and in this side we have the trans 1,2-dichloroethylene molecule and the C2 axis which will go, imagine, perpendicular to this point. Suppose from the plane of this on the plane of the screen it will be going on this direction, and if you rotate it by 180-degree, this chloro substituent will come to this position and this hydrogen will come to this position, and that will be the principal axis. But the symmetry plane of symmetry which is present, that will be contained on the plane of the screen, which will be perpendicular to the principal axis. I hope you are able to visualize the principal axis in the molecule. So that principal axis will be perpendicular to the plane of your screen. Hence, the symmetry elements which are going to be contained by trans 1,2-dichloroethylene will be C2 and sigma H. Hence, the point groups which will be assigned to cis and trans 1,2-dichloroethylene will be C2V and C2H. Now let us come to the next question. The point group of naphthalene is D2D, D2H, D3D and D3H. So if we draw the naphthalene molecule in such a way, it will have a C2 axis of symmetry, which suppose is going through the two junction atoms. And another C2 axis of symmetry will be contained by the naphthalene molecule, which will go in this direction. Hence, you can use the flow chart for your reference, and the point group which will be assigned to naphthalene will be D2H. Because if we start from the flow chart, you can see that the molecule is not linear and it is also not tetrahedral, octahedral or icosahedral. Further, if you see, the molecule is having a sigma H plane of symmetry, hence, and two C2 axes of symmetry are also present which are perpendicular to each other. Hence, if you move in this direction in the flow chart, you will see that the point group which will be assigned to the molecule will be D to H. Okay. So, with this, we have solved the questions which are present in today's tutorial. Let us move from the beginning once again, and if you have any query, then you can let me know. So we started with the simple definition of element of symmetry in a molecule. Then we talked about such an element of symmetry which is present in all the molecules in nature, which is the identity, which basically means no change in the object. Then we talked about a mirror plane which is perpendicular to axis of symmetry, as well as the inversion center which maps an object from xyz coordination in space to minus x, minus y and minus g coordination. Then we also talked about improper rotation of axis, which means rotation by an axis followed by perpendicular to a plane of symmetry. Then we also talked about sigma v plane of symmetry and the equivalent of S2 improper axis, which was the center of inversion. After that, we discussed about the optical activity of mesotartaric acid, how despite containing two chiral centers, this molecule is achiral because of having a plane of symmetry. Then we also talked about staggered ethane point group, which came to be D3D. And we also looked at molecules which contain only a mirror plane but no rotation axis, and the point group which is assigned to such molecules is CS. Then we discussed about distinguishing CN from SN, and we also discussed about the point group of octahedral molecules. Then we looked at these four molecules which are BH2Cl, CH3Cl, NH2Cl and HOCl, and we saw out of these four molecules, BH2Cl was the only one who possessed C2 axis of symmetry. Then we also figured out that a cube does not have the symmetry element C6 out of all these four different axes of symmetry. And I have also listed the definitions of the symmetry elements mentioned in the question. And we also discussed the point groups of cis and trans 1,2 dichloroethylene, which came to be C2V and C2H respectively. And then we discussed about the point group of naphthalene, which came to be D2H after going through the point group flowchart. Okay, so I hope you do not have any queries for with the questions. In this week's lecture, towards the end, I think Newman projection and Sohor's projection was also taught, but since it was only touched in the last lecture, so I'm going to include questions from that topic in the upcoming tutorial. Okay?
Yeah, ma'am.
Okay. So thank you very much.
Thank you, ma'am.
Okay.
We can access the video from YouTube also.
Uh, yes. What did you say?
We can access these slides from YouTube also. I didn't write anything because I have a pure class.
Actually, I think I'm having some problem with the speaker of my laptop. Can you please type here?
Okay, ma'am.
Yeah, please type. I'm here. Yes, yes, you can access. I'm going to upload this recording of the of this slide of today's tutorial on the same channel. I hope you were able to find the channel, right?
Yeah, yeah, ma'am. I find it.
Yes, yes.
Actually, that video helped me a lot for naming section. I have a lot of doubt. I repeatedly watched it and I understood all those doubt also.
Okay.
The one doubt that I discussed with you today.
Yes, yes, yes. I'm glad. So yeah, the same same way, this video will be also uploaded on the same channel, and I hope you are able to access the slides as well, right?
Yeah, I get the slide also. Okay, I completely watch all those videos. When I write at that time also I write all those naming. But I have a doubt and that came I didn't write the priority list and I did write the naming of some of the acid also. OMS gap that also I didn't write. I know that, but I didn't write that time in the at the time of class. So that too, I write after that, and I watch the video repeated. Then I have a lot of little bit doubt about Spyro and bicycle also.
Hmm.
That time I repeatedly watch. I understood all those points.
Okay, okay, very good. Okay, then the same way I'm going to upload the slide also in the link which is provided to me from NPTEL site. I think you can access it that way. And the video recording also I'm going to upload.
Okay, ma'am, no problem. Thank you.
Okay. Thank you very much.
Thank you very much.